Thank you very much. Great pleasure to be here. Now, I've got to sort of apologise for one thing, that I was invited several weeks ago to do this, and I eventually agreed about a couple of weeks ago, but I've had a very busy last few weeks, including a very intense conference that we've been running here in Edinburgh for the last 3 days, which I've done about 4 different speeches and chairing events, etc. So what I didn't feel I could do was do a lot of research into the latest situation on the Scottish energy situation, or tailor a presentation specifically on Scotland. I used to be, just by the way, so you know, I was brought up in Scotland. I was brought up in East Kilbride, just south of Glasgow. I know my accent doesn't give it away. My parents were English, but we moved to Scotland, so I know a bit about Scotland. I used to look carefully at the Scottish energy situation when we were doing the Climate Change Committee overall in the UK, and we would come up to Scotland and look at the Scottish particular aspects of it. But given that I haven't had time to dive into Scotland, I've gone to completely the other end of the spectrum, and I'm going to talk about the global challenge, and I'm going to talk about the role of how we achieve a global economy and the role of development banks, of which national investment banks are part. And just to be completely open, this is actually a presentation that I gave to the Asia Infrastructure Investment Bank in Beijing earlier this year, who have rather a lot of financing to do throughout Asia and along what China calls the One Belt, One Road. And the issue of what they should do, we're working with them in my commission, on what they should do to have green criteria for their development financing is rather important. So what I'm going to try and do is talk about what are the big challenges in building a low-carbon economy, and then at the end, what does that imply for the particular types of finance which are important to build a low-carbon economy. I can have the first slide. The overall challenge, which in this thing that I chair called the Energy Transition Commission, and by the way, there's a report and there are some copies outside if people want to know what the Energy Transition Commission is. But in that commission, it is a group of companies and also NGOs and climate experts who are committed to achieving 2 things. One, that we will meet the Paris commitment of well below 2 degrees centigrade, and 2, that we will deliver more energy for the parts of the world which need more energy. What you can see on this chart is energy use per capita. It's in gigajoules. For all of you who know exactly what a gigajoule is, that's pretty obvious. And as you can see, it varies quite extraordinarily from 290 gigajoules per capita in the US, but it's 28 in India. Europe's about 130. If you try and work out how much energy you would roughly need to have what we think of as a sort of modern standard of living, able to drive a car, well-heated house, you know, etc., the products and services we have, and if we got more efficient, maybe 80 to 100 gigajoules is not a bad figure, which suggests that from where we are in Europe, we can get much more efficient and still have a perfectly good standard of living. But it also says that however efficient a country like India is, it's going to have much more energy. So, challenge number 1, how do we provide some more energy in parts of the world which need it? How do we do it? Can we have the next slide? Within carbon budgets. Many of you may be familiar with this. If you work out how much carbon the world can emit from the onset of the Industrial Revolution, when we really began to have significant amounts of anthropogenic carbon emissions, something like 3.7 billion tons of carbon dioxide is not a bad measure. But if you take off what's been emitted already since the Industrial Revolution, if you take off what will probably be emitted as a result of agriculture and land use, the bit which is left for the energy system and the maximum that we can emit this century and still hope to stay below 2 degrees centigrade, not a bad figure, take 900 gigatons of carbon. And we are emitting now at a rate from the energy system of about 42 gigatons of carbon, so that isn't going to work. And in order to stay within that budget of 900 gigatons, we've got to get 42 down to about 20 by 2040 and about 0 by 2060, 2070, and keep it there. So the question that we are asking on the Energy Transition Commission is that possible, and how do you do it? And we focused initially on the period to 2040, and if you can show the next slide, please. And what we argue is that you can think about how we get emissions down from 47 now to 20 by 2040, well, no, 47 as they would be under business as usual in 2040, because they'd actually gone up from the present level. How you get that down to 20 by 2040, and you can think about it in 4 elements, of which, over the next 24 years, by far the most important is to decarbonise the electricity system and then to electrify everything that we can work out how to electrify across the economy. It's not just taking the carbon out of existing electricity, it's applying electricity to more functions in the economy. However, it's also going to be very important to decarbonise other sectors beyond power, and I'll come back to that. It's incredibly important to improve energy productivity growth, the extent to which we get income per unit of energy, to be more efficient about our use of energy. And it's also very important within our use of fossil fuels, as much as possible, to move from the really dirty end of fossil fuels, which is coal, to the less dirty, but still in the long-term problematic end, which is oil or best of all, gas. Now, the good news is that we think, number one, is doable, and much more doable than I thought 10 years ago when I was the first chair of the UK Climate Change Committee. Back then, we started by doing a whole load of analysis of what we thought would happen to the costs of producing electricity in different ways. And I have to say, although we forecast that wind and solar costs would come down, I now rather hope that people have just destroyed all copies of our initial reports, because they're a bit embarrassing, because we totally failed to understand how rapidly the cost of wind and solar would come down. If you look at this chart, between 2009 and 2015, the cost of wind has come down by something like 65%, and the cost of solar PV by something like 85%, but it's gone on further since then. This 2015 cost is about $60 per megawatt hour, but we are now seeing bids both onshore and offshore, even offshore, which are lower than that. Solar is even more dramatic. This figure here again is about 60. In Saudi Arabia, there have just been an auction for solar PV at $18 per megawatt hour. 1.8 cents per kilowatt hour. You, in your household bills, are probably spending about 14 or 15 pence per kilowatt hour, about 19 cents per kilowatt hour. This is a fraction of that. Now, admittedly, we all have to admit Saudi Arabia is slightly sunnier than Scotland, so the lesson of that might not be immediately relevant. The other bit of great good news is that the cost of batteries is coming down. Next slide, please. This shows how far the cost of batteries, which are a crucial thing to build an intermittent renewable system, back at about $1,000 per kilowatt hour storable back in 2010, down to $273 by 2016. I'm absolutely certain they'll be below $150 by 2020, and I think quite possibly they'll be below $100. And the crucial bit of analysis that we did in this study is to answer the question, can you build an electricity system which is near total renewables, which gets 85 or 90% from renewables, and actually from intermittent renewables, even if you're not lucky enough, like Norway, to have enormous amounts of what's called dispatchable renewables, which is hydro. And the answer we give is, yes, within 10 or 15 years, you will be able to build systems which are 85 or 90% renewable, essentially wind and solar, and you will be able to back those up with lithium-ion batteries and with gas turbines running only a small percentage of the year, maybe 10% of the year, and the total cost of those, we have said actually on the next slide, could be as low as $70 per megawatt hour, 7 cents per kilowatt hour. But again, I think I'm going to be embarrassed by these calculations in 10 years' time. I think it is going to be lower still. So I think the cost of a near total renewable system is getting to the stage where it is going to be cheaper than fossil fuels, certainly than coal. Indeed, I was telling you something about America. The American coal industry is only going to keep going if it is subsidized, because wind and solar in America is very cheap. Actually, that's again, geography matters. America turns out to have one of the most favorable places for wind and solar. There's a lot of empty space in the middle of America. The cost of land is very low, it's pretty windy, and it's pretty sunny. But in that environment, the costs are getting dramatically low. So what we should do, as one element of our strategy, is to move as fast as possible ahead with decarbonising and heading for total decarbonisation of our power systems. And as we do that, we should be trying to electrify as much extra of the economy as possible. The next chart is all a bit crowded, you won't be able to take it in quickly, but we certainly think that by 2030 or so, 35% of fossil fuel use in the buildings of the world could be replaced by electricity, essentially to do heating or to do air conditioning. Again, one of the things to remember is that in most of the world, the big challenge on temperature is actually air conditioning, not heating. Focus on how we're going to heat ourselves is a peculiar northern latitudes focus, and when you get to India, where I've recently been, not exactly what they're worried about. We can electrify much more buildings. The next page, we can electrify, we believe, a lot of automation. Essentially, I think the future for cars is electric. And actually, I've just been in Germany talking to some of the big car manufacturers, and they all are basically saying the future is electric. And therefore, I welcome the fact that from 2032, there will be, it's not that there will be no fossil fuel cars in Scotland. I think there will be no new sales of fossil fuel cars. But I welcome the fact that that has been brought forward to that date in Scotland. As always, England is lagging behind with a 2040 target. You led us on banning smoking inside. You led us in levies on plastic bags, and you will lead us again on this issue, but we'll catch up eventually. So the future is decarbonise electricity and then electrify as much as possible. And actually at the global level, if I can have the next chart, the point to understand is we are going to need more electricity. And even if we get much more efficient at the use of it, we're just going to electrify more of the economy so that electricity is going to go up very fast. I mean, in India, where I've just come back from, we're talking about increases in electricity demand there from 1,000 terawatt hours to, by the mid-2030s, 3,000 terawatt hours. But even in countries like us, and even where we are getting more efficient, because we will electrify more of the economy, our total electricity use will probably go up. Now, that is the optimistic part of the story. That's what we should do, and it's doable. But it's not enough. Because if I have the next chart, once we've done that, and we get to 2040, and if we've got global emissions down to 20 gigatons, what we'll then be coming up against a lot of is that there's a lot of sectors of the economy where it's not easy to say, electrify it. You can't necessarily, and perhaps forever, electrify aviation. Electrification may not work as well for long-distance, heavy goods vehicle trucks as it does for relatively short-distance cars. Steel production and cement production are very big sources of emissions, and it's not clear that the answer is simply electrification, though in steel it actually may be indirectly through the use of hydrogen. Now the good news in these what we call difficult to abate sectors, if we look at the next chart, is that for every one of the major ones, and what we're talking here about is steel, cement, we need to remind ourselves what's on the chart, yeah. High temperature processes in various parts of India, steel making, chemicals, aviation, shipping, road transport. For every one of them, you can tick off and say, here's a potential solution. You either use hydrogen to make steel rather than using coking coal, or you use biofuels to produce aviation fuel rather than fossil fuels. But for all of them, there are at the moment challenges of what is the cost, things like biofuels, is it competing for a land with biodiversity, with food, etc. And the fundamental challenge we have here is that the way forward on these sectors is nowhere near as clear as it is on what we do with electricity and what we do with cars and what we do with building heating. And what we need to unleash here is the same success that's occurred in the renewable energy space. If you look at the next chart, what I would argue is that what has happened in renewable energy is one of the greatest modern successes of a fruitful relationship between the role of government and the role of the private sector. Because those cost reductions that I showed you on wind and solar, they would never have occurred without forceful government policy. What happened was there was initial R&D driven by government, which got the initial ideas through the basic scientific labs, and it was a deployable technology. And then there were large subsidies up front, where we did pay for offshore wind and solar at much higher costs than fossil fuels. And a lot of people said, well, why are you doing this? This is absolutely absurd. This is incredibly expensive electricity. But the very process of subsidizing it drove it to scale deployment, drove what are called learning curve effects, and the prices came down, and the prices have now come down to the level that we hardly need subsidy. And that process, which has been so successful on wind and solar, is what we now need to repeat for some of the technologies to solve the other problems, technologies perhaps such as what's called carbon capture and storage, which may be essential in the cement and steel area, or I think particularly the development of a hydrogen economy, which I think is going to play a crucial role. We also, however, next slide, need to produce across the world a revolution in energy productivity growth. If we define energy productivity growth as income per unit of energy produced, GDP per unit of energy, in order for the numbers to add up, in addition to decarbonising energy supply, we've got to start improving that ratio at something like 3% per annum, and at the moment we're running at about 1.7% per annum across the world. And then finally, within our use of fossil fuels, can you flip on two please, next one. Within fossil fuels, what we've got to do is commit to reducing fossil fuel use, but some of them before others. Basically, if we are to have any hope of achieving well below 2 degrees centigrade, we have got to reduce coal use in the world by 70% or so by 2040. But actually, for the developed world, it's even more dramatic than that, because we don't know yet how to produce steel economically without coking coal. So what's called thermal coal, which is the stuff we put in power stations, has got to come down by about 75 or 80%. And we're not going to be able to stop the Chinese and the Indians burning some coal. So essentially, coal use in power stations in the developed world has got to stop tomorrow. I mean, we've just got to eliminate that as rapidly as we possibly can. The other two, oil and gas. Gas is the least harmful of the, in terms of the energy you get relative to the CO2. So that probably doesn't have to fall by 2040, but it mustn't go up. And oil we've got to bring down by something like 30%. Now, the question people sometimes then ask, and this links through to the issue of the role of development banks and the role of finance. And could you go on 1, 2, 3, please? This one. Okay, is this affordable for the global economy? Where on earth are we going to get the savings and the investment to afford this enormous transformation of the global economy? But once you actually look at the figures, and at the total global figures, at the macroeconomic level, this is not a problem. Over the next 15 years, in order to build a low-carbon economy, rather than a business-as-usual high-carbon economy, yes, the global economy has to invest some more money, probably something like another $6.8 trillion of investment. But what's interesting about that is that's 450 billion per annum, which is about 0.5% of global GDP. And the world saves and invests now about 22% of global GDP. So seen in the sense of how much we save and invest, this is only about 2%. This is actually in terms of the total amount of investment that the world does, not a huge change. And actually, what's very interesting from a finance point of view is we live in a world where there seems to be too much savings pursuing too little investment opportunities. Because that's the only way economists can make sense of the fact that real long-term interest rates are negative. right? The cost to the UK government of borrowing for 10 or 20 years on a real index-linked bond is now negative. The nominal cost is below the rate of inflation. These are phenomenally low interest rates, and you might therefore think that with this phenomenally low interest rates, it would be the easiest thing in the world for the private sector to say, well, people want investment opportunities, let's fund this investment. But the challenge is, of course, that the balance of the investment has to change. So if you could show me the next slide. What we have to do is, I'll come back to this in a minute, within energy exploration, production, generation and distribution, we actually need slightly less of it, but I'll come back to the composition of it in the next slide. But actually one of the interesting things to do is that the biggest thing that changes in terms of investment need is not the production of energy, it's in the use of energy. Actually, some of the most important forms of investment are in new heating and ventilation and air conditioning systems, new forms of business of insulation, new motors, etc. A lot of the big bits of total investment required are lots of things that lots of households and lots of small businesses and lots of business and large businesses have to do, rather than simply the things that people tend to focus on, which is windmills and wind farms and solar energy. But of course we do need those as well, because if you go on to the next chart, within the energy production, exploration and distribution system, we need, compared with business as usual, hugely more low carbon power. And yes, we will still need in the world to explore some further and distribute some more fossil fuel distribution. I mean, we're not going to be able to stop that in India, don't kid ourselves, but we've got to produce a relative shift of much more of that and less of that. Now, that then brings me to the challenge for finance and development banks. Why is this challenging? And I think the answer is there are two major challenges that we have to think about. The first, if you put up the next chart, is that there's something very important about the structure of low carbon power, which is that pretty much all the cost is up front, right? A windmill or a solar power station, a solar PV station or solar thermal, which may work in some desert locations, you invest, and then there is zero operating cost, or very close to zero operating cost. And this means that compared with a fossil fuel plant, the cost of capital, the rate of return that investors want, is not just a bit of the economics, it's the overwhelming bit of the economics. And one of the reasons why the cost of wind has come down is partly better, bigger turbines, but it's also because the financial flows are working with better, in a better fashion, so people are willing to invest at low rates of return. As I said, I've just been down in India, and in India, in order to build wind systems, at the moment, the project developers are having to pay investors about 10% per annum. The cost of capital is about 10%. But we live in a world in which there's a whole load of investors in insurance companies and investment and pension funds, which can only get a negative real return on buying a government bond. So this fundamental issue of how you take a world in which there are lots and lots of people who'd like to be able to invest in insurance company or pension funds at least a bit more, 3% would be better than zero. How do you put that together with the fact that there are a whole load of projects which are presently being charged a much higher rate? And that, I think, is one thing which you need the potential role of public sector banks and development banks to help bridge that. And that was what I was talking with about the Asia Infrastructure Investment Bank. But the other key challenge is that, think about all that energy efficiency expenditure. Not the big wind farms, the big solar farms, but the energy efficiency expenditure. Here the problem is that a lot of the decision making is not driven by a large business thinking professionally about a rate of return. It's a householder thinking about whether they invest in better insulation in their house. And for us economists, it is a very sad fact that ordinary human beings, by which I mean non-economists, do not spend their evenings sitting down with a spreadsheet and working out what the net present value of investing in well-insulated houses or not insulated houses is. They don't think like that. They don't make conscious decisions. And so what we need in that area is ways to reach those households with simple products which help them understand what they can save from insulation and helps them through those processes. And one of the problems that I think the UK government has had for the last 10 years is it's tried to address this issue by an overly complicated set of financial instruments which assume a degree of sophistication on the part of an individual decision maker thinking about their household economics that they don't have. So, my final point therefore is, I think for Scotland, to come back to Scotland, the two big things to think about in terms of the role of finance and the potential role of a public sector bank is, how does one reduce the cost of capital, the required rate of return for large infrastructure developments like solar and wind, offshore wind in particular, and onshore as well? How do you bring that down while still, from a public purse point of view, making a return? Because if one can do that, one can unleash yet more investment and get a lower price of electricity for the Scottish people. And then in addition, how do you create simple financial packages to go to individuals, small businesses and residential households that do not think in sophisticated terms and make it easy for them to invest in, for instance, the improvements in building insulation, which will make them better off, but they're not going to sit down with a spreadsheet and work it out. Thanks very much.